In this third part, we talk specifically about artificial intelligence. We started with the basics, how a bit works, how it's made, and what you can do with bits. We then saw the use of digital electronics in the construction of a calculator. We've seen how it works. Finally, we moved on to describe a computer, with the logic gates and, or, not, and how you can use them to program any processing process. We talked about the machine of Alan Turing, the one who first described the basis for building a programmable computer. A tape that contains the so-called elementary functions and their execution in sequence, one after the other with the possibility of changing sequence according to the logic of the program. A tape that goes up and down and with which you can describe any work, any operational logic, just break it down into elementary functions. He also theorized the possibility that computers would equate humans' ability to reason within 50 years, hypothesizing a test, the Turing test, to establish if and when this happened. The test consists of placing a man in the middle of a room and putting him in communication with a woman on one side and a computer on the other, without the possibility of knowing the identity of one or the other. Man could communicate freely with both, and if he was unable to identify the computer, it meant that the machine had equalized man's rational capacity. Maybe with artificial intelligence, the computer is about to pass the Turing test. We have seen what a program consists of. We analyzed the sort program, which with a series of cycles rearranges the letters even though it does not know the alphabet, thanks to the fact that with the transcoding table ASCII transforms the letters into numbers and vice versa. We then saw how it is possible to try to predict what the weather will be like tomorrow, even if we have deliberately trivialized the problem to make it understandable to everyone. It helped us to understand that there is a dichotomy between the way of reasoning of a computer, which is basically a calculator, and the way of reasoning of our brain, which has little to do with numbers. For a computer, each number is absolutely different from the others. It doesn't matter if they are infinitesimal numbers or huge values. The numbers are all different. And this has the consequence that for a computer the answers can only be yes or no. Whereas in reality we are always dealing with a series of nuances. After seeing the various cycles with which a Turing machine rearranges the letters, we also said that with the most advanced languages it is enough to write the word sort, and no longer all the instructions in machine code, to achieve the same result. In a programming language more advanced than machine language, the sort program has become an elementary function, a single command. Thanks to the ever-increasing speed of computers, we have gone from thinking about cycles in machine code to sort as a single command, as an elementary function, without worrying about the machine code underneath, so much so that everything is still completed in fractions of a second. But we always program according to the Turing machine schematic, even though now the elementary functions in slots are complex processing, such as the sort, which we no longer worry about in terms of machine code. Thanks to the enormous speed of execution, we don't have the perception of how many instructions are actually executed when we write what has now become a single instruction, sort. Finally, we talked about a different way of approaching programming. The increasing speed of computing of computers has led to programming at a higher level, where in the individual slots of the Turing machine there are commands that perform increasingly complex functions but which, thanks to the ever-increasing processing speed, we consider as elementary functions, without worrying about the huge amount of machine instructions that each of them unleashes, still performed well under a second. We think at an increasingly high level in the decomposition of processes, relying on complex functions that we allow ourselves to consider elementary thanks to the speed of calculation of computers. The underlying machine has always remained the same. It always works in the same way with the logic devised by Alan Turing. It's just much, much faster. A speed that we cannot realize, because it is beyond any of our experience. At the same time, significant steps have been taken in the experimentation of a different software architecture, which overcomes the limit of bits, on-off, and the difficulty of contextualizing a numerical value to consider practically equal values that for a calculator are always different, or one or the other. The new software architecture is inspired, albeit only figuratively, by the neurons and synapses of our brains. Hence the term artificial neural networks. Logic consists of searching for sequences of bits based on predefined patterns, which correspond to very precise meanings and useful for identifying certain parts or characteristics of an object, be it a sound, an image, or a mix of words arranged in a certain order. Passing through many layers, each specialized in a certain recognition, a series of partial, weighted information accumulates, which at the end allow you to establish what object it is, what piece of music, or what the content of an image is, and so on. The architecture is generic because, based on the result of the individual function and its weight, it decides which function to invoke in order to proceed with the identification. The process thus follows different paths, even in parallel, and hence the term neural network. We mentioned that bit sequences are searched in relation to predefined patterns. But who defines the models? They are defined by the same software architecture during a different preparatory processing phase, called training, or machine learning, during which a huge amount of objects are provided to be analyzed, each with its associated solution. In this phase, the software performs several test cycles, travels along various roads, calculates an enormous number of weights and, based on the result provided by humans, learns which roads and weights identify that particular object provided as input. The wider the type of functions capable of identifying specific types of objects and the larger the quantity of objects provided during the training phase, the more the tool is able to provide correct answers, that is, it is able to show itself intelligent. For illustrative purposes only, let's do yet another exercise. As we know, the computer is basically an electronic calculator, and as such it has all the electronic circuits built to do the four operations: addition, subtraction, multiplication, and division. So if we have to develop an algebraic equation, we will simply have to write a program in the classic form, which analyzes the equation and recognizes the parentheses, extracts the innermost operations, and so on. As it is based on a calculator, the computer already has the electronic circuits built ad hoc to do the four operations and respect the rules of signs. But let's assume on a purely academic basis that we want to take advantage of artificial intelligence to teach it how to solve algebraic equations. We will have to equip ourselves with software modules written ad hoc to recognize the innermost parentheses, others to respect the rules of plus and minus signs. During the training phase, called machine learning, we will provide them with some equations and their solutions. The software architecture of neural networks will carry out a series of tests, following all possible ways, and will discover that by applying the right rules in compliance with parentheses and signs, it obtains 100% of the results that man has provided it. This becomes his own database with which he is able to solve algebraic equations. Let's try to understand the meaning of this exercise, which makes no practical sense since the computer is a calculator and at most it must be taught how to treat parentheses, but certainly not the rules of the plus and minus signs. However, it has helped to understand the technique of learning a machine based on what man teaches it and with a statistical approach without understanding the information content of the bits it is processing. However, when this technique is applied to words, to texts, it impresses us because for us humans it seems impossible that the reasoning that we express through words, sentences, actually uses predefined sequences of words that a machine treats as numbers, as bits, and that it uses based on statistics. It seems impossible to us to think that we communicate our thoughts, our opinions, our reasoning, using in fact only phrases already said, already written. But we use words as a means to transfer concepts, while the computer, through training, machine learning, receives the transcoding key from humans, just as with the transcoding table ASCII translates numbers into letters and with the program sort seems to know the alphabet. Let's now analyze an interview with the ChatGPT artificial intelligence and analyze in detail the information content that really took place in the exchange of information. This is an example taken at random with the aim of showing you how an apparently articulated, correct, intelligent flow, in fact consists in saying nothing more than what is known and what is already known. In short, nothing to do with human intelligence. This is the prompt. I have a project at an advanced stage that I am trying to implement. It concerns young people aged 10 to 12 and up. I am in doubt whether to rely on a professor I know and through him to start an experiment, or to contact the CEO of a bank, who knows me, to propose the project and get the bank's support. To demonstrate that it is a program, which follows a predefined flow, even if it uses the so-called artificial neural network to build its response, the flow of the response has clearly followed a pre-established pattern, as any programmed system would do. He begins with a preamble in which he does nothing but repeat what I have asked him, as if to show that he understands and wants to make sure of this. In my case, it adds a description of what can be the peculiarities of a professor, such as academic experience. Then the same thing follows for the bank: financial support, visibility, resources. He then adds a suggestion that is somewhat obvious, trivial, rather than choosing between option 1 or 2, why not opt for both? Finally, he closes with obvious and ritual statements and considerations, wishing me good work. Note that since I did not specify the characteristics of my project, ChatGPT did not add anything in this regard, having nothing on which to rework its response texts, nor did it bother to ask about it. It is obvious that by programming it in the classic way, as he added the preamble and closing sentences, he could have included the request for information on the nature of the project, and this would have given him the opportunity to create an even richer and more articulated response text. But a computer can make this request if programmed and not because it has its own rational thinking. At least that's the case for now. But let's move on. Let's now analyze an interview with the ChatGPT artificial intelligence and analyze in detail the information content that really took place in the exchange of information. This is an example taken at random with the aim of showing you how an apparently articulated, correct, intelligent flow, in fact consists in saying nothing more than what is known and what is already known. In short, nothing to do with human intelligence. This is the prompt. I have a project at an advanced stage that I am trying to implement. It concerns young people aged 10 to 12 and up. I am in doubt whether to rely on a professor I know and through him to start an experiment, or to contact the CEO of a bank, who knows me, to propose the project and get the bank's support. To demonstrate that it is a program, which follows a predefined flow, even if it uses the so-called artificial neural network to build its response, the flow of the response has clearly followed a pre-established pattern, as any programmed system would do. He begins with a preamble in which he does nothing but repeat what I have asked him, as if to show that he understands and wants to make sure of this. In my case, it adds a description of what can be the peculiarities of a professor, such as academic experience. Then the same thing follows for the bank: financial support, visibility, resources. He then adds a suggestion that is somewhat obvious, trivial, rather than choosing between option 1 or 2, why not opt for both? Finally, he closes with obvious and ritual statements and considerations, wishing me good work. Note that since it did not specify the characteristics of my project, ChatGPT did not add anything in this regard, having nothing on which to rework its response texts, nor did it bother to ask about it. It is obvious that by programming it in the classic way, as he added the preamble and closing sentences, he could have included the request for information on the nature of the project, and this would have given him the opportunity to create an even richer and more articulated response text. But a computer can make this request if programmed and not because it has its own rational thinking. At least that's the case for now. But let's move on. The interview continued and I asked him to make a comparison between the two hypotheses, listing the pros and cons of each hypothesis and assigning them a weight from 1 to 10. Initially, he did not understand, and 3 times he replied by listing the characteristics of the professor and the bank, assigning values from 1 to 10, but without making any comparison. A simple list with weights. On the 5th attempt, in trying to be more explicit in what I asked, after apologizing to me each time, he finally produced the following table. When I pointed out to him that the bank was much cheaper, he replied that the advantages of using the bank were certainly greater. But then, why didn't he say it right away? Hadn't he thought about it? Was he distracted? It is only because he does not reason, but only elaborates the texts that we provide him, giving the impression of reasoning. Talking to artificial intelligence thinking that you are talking to a human being immediately turns out to be an apparently intelligent conversation. The interview then continued with a series of exchanges in which I asked him for advice on how to proceed, what to do, to which he promptly replied with textbook texts, in which he listed the best practices, the classic list of how to proceed, market analysis, prototype development, partner search, and so on. Who knows how many lyrics he has in his belly that all say the same thing. I then asked him to focus on the first point he had suggested to me and promptly went on to list a series of classic textbook actions that we can find very easily on the internet. Relying on him, I went on to tell him that among the various points listed, I thought it was important to focus on the system database, and once again me listed a series of classic actions to proceed in this direction. At this point I objected by telling him that I did not agree with the approach in general because it took too much time, while it was necessary to act quickly to break into the market and prevent any possible competitor that would have presented itself once I understood the value and idea of my project. And he proved me right by listing a series of trivial suggestions aimed at doing it quickly. Yes, but all of this requires interest from potential partners. How do I find the right partners? How do I contact them? And ChatGPT immediately replied to me by listing the Ministry of Education, international organizations, foundations, NGOs, universities as the right partners. Perhaps he did not understand the meaning of my objection. But I avoided specifying and went on. How do I contact these potential partners? I also asked him to be more detailed in his answers. And more than once he has diligently listed to me a series of fairly obvious, textbook points. But what else could I expect? They were the most correct and sensible answers to questions that actually required material support to be able to contact at least one of these partners. But all of this is of course beyond the scope of ChatGPT. With those questions I was looking for a solution and concrete support that could come from those who were able to help me materially, for example by introducing me to the right people, putting me in direct contact with those who could get involved in my project. But ChatGPT is clearly not this, and all I had to appreciate was the formal correctness of its answers, perhaps pretending that it was more in-depth to the problem and less generic. But all this can be refined over time, a bit like we saw in our example of programming software that can predict rain. Initially not very precise, the forecasts could gradually be refined more and more. But it is always an elaboration that is based on models, i.e. on simplifications of reality, which can improve over time, reduce the percentage of error that remains present. Concluding. Those who think that ChatGPT could pose a risk in the future, a threat to humans, are mistaken. Impressed by the responses that ChatGPT is able to generate, he fears that it may one day take over humans. This is pure science fiction. Rather, let's worry about our way of being. Let's try not to harm ourselves by relying on artificial intelligence for our laziness in reflecting, evaluating, and taking a stand. Let's not worry about artificial intelligence but rather about ourselves. Let's try to be as consistent as possible. Let's use common sense. Let's get used to reasoning, and let's not look for the truth from machines. Otherwise, we risk looking like the little dog or kitten that you see in the mirror and think that it is another animal of your own. Let's not make the mistake of treating AI as a mirror of ourselves. With the passage of time, surely the current artificial intelligence will evolve into something that we cannot even imagine today. Progress has no limits. It's just a matter of time. It is wrong to rule out a priori that there will not be an artificial intelligence comparable to that of humans. We have no reason to rule it out. Let's just say, however, that man will only be able to build an artificial intelligence equal to human intelligence when he manages to build a machine identical to his own brain. For now, the Turing machine, i.e., all the electronic computers in the universe, based on silicon. Transistors and bits, do not have much prospect in this sense. At least for now, it seems that way. The computer is a very valid tool to support many of our activities. Now also for some mental activities, it writes texts for us. But it's like talking about a brake booster or a car power steering. Artificial intelligence is just an aid to make less mental effort. Everything else, all the intelligence we attribute to it, is the result of our behavior. It is us who look at ourselves in the mirror without realizing that it is always us on the other side. If we try to form an opinion through the answers of artificial intelligence, we are wrong, because true opinions are formed only through one's own experience, one's own common sense, one's critical sense, without letting a machine tell us what is right and what is wrong. Already today we are witnessing an addiction of the whole of humanity to the computer. Only 100 years ago we would not have heard any numbers, no percentages in speeches of any kind, simply because in the absence of computers no one could provide data or statistics of any kind. Today, however, thanks to or because of the computer, we are not credible if we do not refer to some percentage or some statistical data that proves our reason. It doesn't matter the words, the reasoning, it is enough to provide a figure, a percentage, and many people are convinced of our speech. Isn't this also a good reason to worry about computers, even without artificial intelligence? It is to be hoped that the evolution of computers will lead us in the future to have not only artificial intelligence, but also artificial common sense. A machine that, in the face of the problems we have to face, knows how to make us think, knows how to suggest the right key to find the best solutions. A machine that, in the face of the question, how society should be organized all over the world in order to have the greatest number of feline people, knows how to answer and proves in fact that it is right. Let's take this last aspect as the new challenge for computer science, the new Turing test to be passed. Thank you for your attention and have a good day.